So now we will see about some basic definition um, of upper bound, lower bound, and supremum, infimum of a set. So first of all, let's have so R is the set of real numbers, and let's have a set E, which is a subset of R. Then if there exists some constant alpha that belongs to R, then the set then alpha is said to be the upper bound on E if alpha is greater than equals to x for all x belonging to E. So this is upper bound. Similarly, alpha will be called so this is of upper bound, and alpha is lower. Okay, let's call it beta instead. Beta is lower bound on E if beta is less than equals to x for all x belongs to E. So these are two basic definitions. Now we will see supremum and infimum. Then alpha star is another constant, is called infimum. Beta star, let's call beta star as infimum just for consistency, to be infimum of E if beta star is lower bound on E, and any for any epsilon comma beta, any epsilon greater than 0, beta epsilon plus beta star plus epsilon is not lower bound. Then beta star is called infimum. So here we need to see a very subtle difference, that if, for example, if there is some well, okay, on this R real line, this is beta star is lower bound. For example, if E is this is E, then this beta star is lower bound, then its gamma star will also be lower bound, because all E is greater than this beta star also, gamma star also. But let's, for this point, okay, if beta star is here, but here the beta star is not infimum, because gamma star is equals to beta star plus some epsilon, that is this distance epsilon. So this is not lower bound. But if we had beta star here at this point, so no matter what epsilon we take, it won't be epsilon greater than 0. Beta star plus epsilon will fall somewhere inside. So there will be some x here for which beta star plus epsilon is greater than that x. So then beta star plus epsilon won't be lower bound. So this is infimum. But otherwise, if beta star is here, it won't be infimum, because for that beta star some gamma star exists that is also lower bound, and gamma star is greater than beta star. Similarly, talking about this alpha star as the supremum, this is called supremum if alpha star minus epsilon epsilon greater than 0. Alpha star is upper bound, but alpha star plus epsilon is not upper bound. On E, then alpha star is called supremum. Having said all this, let's realize that this alpha star and beta star, which we saw, may or may not belong to E. For example, if your E is open set, then this will lie on the boundary which is not included in E. So alpha star and beta star won't be a part of E, and so whatever, for example, 2, 3, so this 2 is the lower bound, and also the 2 is the infimum, because whatever 2 plus epsilon, so for the 2 plus epsilon you say 2 plus epsilon by 2, that will be belonging to this set 2, 3, and will be smaller than 2 plus 3. So 2 plus epsilon by 2 won't be lower bound, and 2 plus epsilon by 2 will be smaller than the lower bound. So 2 plus epsilon is not lower bound, and so this 2 is infimum. Similarly, 3 will be supremum. On the other hand, if we have this closed set 2 to 3, then 2 is infimum and belongs to E. Fine, because for 2, any number is greater than equal to 2, any number belonging to E is greater than equal to 2, and for 2 plus whatever epsilon, it is, for since 2 belongs to the set itself, so 2 will be always lesser than 2 plus epsilon, and that's why this won't be lower bound. So 2 is the lower bound, is the infimum, and this time infimum belongs to the set itself. Similarly for a supremum. So one thing should be clear, that whenever, for example, if alpha star is the supremum and beta star is the infimum, so alpha star is greater than equals to max of E, and beta star is less than equals to min of E, and equality holds only if alpha star beta star belongs to E itself. That is, alpha star is equals to max of E if alpha star belongs to E. Similarly, if beta star belongs to E, implies that beta star is equals to min of E.